So good morning, students. So this is the continuation of the previous day session. The problem a power n, b power n. Okay, so we have already know about how to draw a transition diagram for the particular language and how to write a transition function. And for this problem, so now we are going to write instantaneous description for the problem a power n, b power n. Okay. So instantaneous description. So I will choose the string A, two times A, then two times B. The instantaneous description is nothing but execute over on the string. Okay. We will take a string as an input. So at initial state, the automata is in Q naught. It's an instantaneous description is also a three triple value. So here the remaining strings yet to be read. Since it is the starting state, the remaining strings are the whole string. That is A, B, B. Okay. So next, in top of the stack. Okay. That is what are all the symbols available in this stack. So right now only is it now. Okay. Since it is a starting state, so right now the only symbol which is available on your stack. Next, turnstile notation. Okay. So after reading the first A, your state will move to Q naught only. There was no any change in the state. Okay. So remaining string had to be read, which is A, B, B. Then the strings available in the stack, that is Z naught, which is replaced by A Z naught. Okay. Next, the turnstile notation. So after reading the another A, the state which is in the same state Q naught, then the remaining string BB, then available symbols on the stack, that is this A, which is replaced by AA. So 2 times A, then Z naught. So these are all the symbols which is available in your stack. Next, so after reading B, your state will move to Q1 from Q naught. Okay, there will be a change in this state, which is Q1. The remaining string, which had to be read, which is B. Then here B, if you are encountering with B means you will start the pop operation. So A which has been removed from the stack. So on the available symbols on the stack only A Z naught. Next, so after reading one more B, the change the state which is in the same state Q1 only. Okay. Then the remaining strings had to be read, which is epsilon. Actually, there is no any remaining strings. Then if it is this is the B input symbol, which is B, so pop operation A is removed, so Z not only. Next, without reading any input, okay, you can make some operation in question automata without reading any input. Your state which moves to Q2 from Q1. Okay, so there is no any input remaining input. If I'm choosing the emptying by stack means, okay, pop operation. Okay, this is the approach for Houston automata emptying by stack. Okay, so this is the instantaneous description for the previous problem. This is your problem A power n, B power n. Okay. Next, see one more problem. Actually, this is homework for you. Okay, very easy problem. See here, construct PDA, okay, M, that accepts the set of balanced strings of parentheses, that is square bracket, by empty stack. Okay, here they have explicitly mentioned as by empty stack. Okay, so balanced string of a parenthesis means, what about the balanced string? So I'm asking you take a paper and write down this problem. Okay, this is your homework problem. So balanced parenthesis means if two times open parenthesis means there should be a two times closed parenthesis. Okay. Okay, if it is one time means you have one time closed parenthesis. If three times open parenthesis means three times closed parenthesis. This is almost similar to a power n, b power n, right? Instead of a, so a, you can treat a as open parenthesis, you can treat a b for closed parenthesis. Okay, the same problem. Okay, so a power n, b power n, almost the same problem. You can replace open parenthesis instead of a and closed parenthesis instead of b. Okay, this is your homework problem. Okay, so take a paper. So I'm asking you to everyone to take a paper and note on this problem. Okay. Kindly post in the chat box. Shall I move to the next problem? Okay, thank you. So this is your next problem. A power n, b power 2n. Okay, where n greater than or equal to 1. Okay, first I'm going to draw transition diagram, PDA transition diagram. PDA transition diagram. First, I will start in the state Q naught. Okay, as usual thing, start in the state Q naught. And your stack. At initially in the stack, initial stack symbol which is Z naught. Okay, so I have to write the moves. Okay, so that is the same looping. So an initial, since this is a power n, b power 2n, right? So a power n, b power 2n means the language means if single a means, okay, if single a means 2 times b, right? Then 2 times a means 4 times b. Okay, so this is almost the string of this language. So every string, that is all string, should start with a. Okay, so a, this is the input symbol. Then next, in this place, the symbol which is going to be popped. Okay, so z naught, which is going to be popped. This is top. Actually, this is the top of the stack symbol. So now the top of the stack symbol, which is z naught, which is going to be popped, and here the symbols which is going to be pushed onto the stack. So here I am writing here a z naught. Okay, so your current reading input which is a, because here all strings should start with a, then z naught, which is top of the stack, which is going to be popped, and after the bar, the symbols which is going to be pushed onto the stack. See one thing, I made one mistake. See, this is the problem of a power n, b power 2n. Instead of pushing a single a, I am going to push 2 times a. If I am reading a single A means I am going to push 2 times A is it not? Okay. So if I'm reading single A means I'm going to push 2 times A along with is that not? Okay. So after A, B, which is also possible, and after A combination, which is also possible. So I have to write after A combination. So after then again A, the coming input symbol from the tape, which is A. Then what is the top of the stack symbol? Here, what is the top of the stack symbol, which is A, right? The top of the stack symbol, which is A. If I'm reading a single A means this is the symbol which is going to be popped. Okay. See, if I'm reading a single A means I have to insert 2 times A along with the top of the symbol. Just 3 times A. Okay. So here first this A is going to be popped. I will take first I have taken this A from out. Okay. Take out from the stack. So single A means 2 times A. I have to put 2 times A. Okay. So along with the top of the stack. So this is for single A. So for single, if you are reading a single A from the input tape means you are going to put 2 times A. Okay. See. Next, if you again A is going to be read means okay, this is the state which is A now. Okay, top of the stack which is again A. So if single A means 2 times A, which you have to put inside the stack. Okay, so this is the looping structure. So almost the A part which is going to be over. Next, what about the B part? See, my input symbol which is B. Okay, the coming input symbol from the tape which is B. Okay, what is the top of the stack? It should be A. Yes, A. So see here B is the indicator. So for this problem like A power n, B power n and A power n, B power 2n. For this problem, B which acts as a indicator where you will start your pop operation. So these kinds of problem actually had some indicator, right? And also A power n, B power m, C power n. So the first problem, right? So in this problem also it has some indicator. So why I'm using the term indicator means if such problems have some indicator means where you can start your pop operation means that languages actually that problem actually that languages which comes under deterministic Pushton automata. Okay. While drawing the Pushton automata, you won't consider you won't consider anything in your mind. You're going to draw deterministic. You're going to draw non-deterministic. That is not at all necessary for constructing PDA problem. But in FTA, you have to keep some points. You have to keep some points while you're going to draw whether it is a DFA or an FA. Okay, because both have some unique property. But in PDA, it is not at all necessary to keep such things while constructing a PDA problem. By automatically, some problems are comes into the category of deterministic Pushton automata. Okay, so like this problem A power n, B power 2n, then A power n, B power n. So these are all the problems by default they will come into the category of deterministic Pushton automata. Okay, so in the next day sessions we will see about the example for a non-deterministic Pushton automata. Okay. So the coming input symbol from the input tape which is B and the top of the symbol there should be A, right? This is going to be popped and since it is the B, so there is no any push operation. Okay, so epsilon. So first I'm taking here say example for this. Okay, AA 4 times B. Okay, so this is my example. A 4 times B. The first A which has been removed. Okay. Next, while reading the first B, it will goes to the state Q1. From Q1 again on looping structure because there is n number of B's are possible after A and also after single B. Okay. So if again the input which is coming from the input tape which is B and top of the symbol which is A, okay, if it is means uh, there is no any push operation. Again this A is removed. Since it is a looping structure, okay, since it is a looping structure for third B, this A has been removed. For fourth B, this has been removed. Okay. Next, anything input is available from the input tape? No. Okay, that is empty. So input tape which is almost empty. So if there is no any string, that is without reading any input, it can proceed. Okay, PDA. So there is no any input further to proceed. And top of the stack which is Z naught. Okay, here I am choosing pushed on automata by emptying the final state. Okay, by emptying the final state. By emptying the final state. So since it is the emptying the final state, okay, there should be that initial uh, starting symbol, pushed on symbol, which has been available at your final state. Okay, so this is your final state, which is Q naught, Q2. This is your final state. Okay, first empty for there is no any input, so epsilon. Then top of the symbol, top of the stack, Z naught, which is going to be popped again here. The strings, the symbols which is going to be pushed again is not. Okay, so I will take first Z not from I will take out Z not from the stack. Again I pushed on into the stack. Okay, so this is the matter. This is the problem which comes under the category by emptying the final state. So epsilon comma Z not by Z not. Okay, so this is the complete PDA for the problem A power n B power 2n. Okay, see, if I'm choosing the symbol which is A double B. Okay, for this A double B. For this, see here, um, stack for A double stack, the stack, but in initial stage that will be Z naught. Okay, so from the input tape, the first symbol which is read from the input tape, which is A. Okay, what is the top of the stack symbol, which is Z naught. So if single A means 2 times the A has been put inside the stack along with Z naught. Okay, so for single A means we're going to insert 2 times A into the stack. Okay, and next, what about the next input string from the input tape, which is B, right? So if it is B, next input symbol from the input tape, which is B. Okay, then top of the stack, which is A. Okay, top of the stack, which is A means there is no any push operation. Okay, so that A is removed. Okay, that A is removed. Next, coming to here Q1. So again looping structure. Okay, again the input from the input tape, which is B. This is this B. Okay, for this B, last B, and the top of the stack, which is A, okay, which is going to be popped, and there is no any push operation. So again, A is going to be popped. A is removed. Okay. Then there is no any input symbol after B, that is epsilon empty string. Okay. And top of the stack, which is Z naught, since it is an emptying by final state, Z naught, which is removed at first. Okay. And this is the symbol which is going to be popped. Again, this is the symbol which is going to be pushed. Okay. So finally, Z naught only, which is available in your stack. Okay. So this is called emptying the final state method. Okay. So for this string, for this string, so every string, if 3 times A means 6 times B, 4 times A means 8 times B. For all strings, it is applicable. This transition diagram is applicable. Okay. So transition PDF or transition diagram is over. Okay. Is it clear? Just chat 2 times A. Why are putting 2 times? That is the mechanism. Actually, um, every PDF or every problem like a power n, b power n, a power n, b power 2n has some logic. That's the logic here. Okay. Uh, so without having any practice means it is very difficult to find the logic at the time of your examination. Okay, so you have to keep memory in question automata. A power n, B power n means so A while reading A the push operation, while reading B pop operation. A power n, B power 2n means while reading A push operation but 2 times. This is the actually logic. Okay, so behind this PDA. Okay, so without this logic we can't able to design this PDA. Okay, so every problem has its unique logic. Okay, Swati. So, like in further chapters, we will see about a W power reverse, then W power reverse. Okay, so many problems are available. Okay, every problem has its own logic. Okay, so what about others? Is it clear? Is it clear? No, no, no. Sometimes for C, W power R, which has its own logic means W power R, which has its another logic. Okay. Um, I have not seen some similar logic for many of the problems. See here, A power n, B power n, the same logic which is applicable to parentheses. Okay, some problems, some logics are common. Okay, like A power n, B power n means the parenthesis. 2 times open parenthesis means 2 times closed parenthesis. Okay. So next, so transition diagram over. Okay. Uh, Next, that is the same transition function del. Write the transition function still. So del of first at initial state q naught. Okay. Then the coming input symbol from the input state, which is A, the top of the stack, which is Z naught. Okay. So del means actually 1, 2, 3, 4, 5. 5 moves are available. So 5 transition function del which is available. This is one. Okay. Which means the state which is the same state. Okay. Then Z naught which is replaced by A Z naught. Okay. Next for the second, so del of Q naught, then again the input symbol from the tape which is A. What is the top of the stack which is A, which means this the same state only, and um, this A top of the stack which is replaced by 2 times A along with this A. Okay. a single A, top of the stack, this top of the stack symbol, which is replaced, replaced by 2 times A along with that symbol. Okay, that's the procedure. Next, what about B? From Q naught, current state Q naught. If the symbol from the input type, which is V, the top of the stack, which is A, means okay. Now the state which is changed from Q naught to Q1, and for single actually um, there is no any push operation. Okay, so here you have to write epsilon only. Okay, while reading B, there is no any push operation. So while reading A, there will be a push operation. A 3 times A. Then del of Q1, then input symbol from the tape, which is B, then top of the stack A. So the same state Q1, there will be no any push operation. Next, the last one, see, this is the one, the last one. From Q1, so no any input symbol from the tape. Without reading input symbol, it can proceed. So null string epsilon, top of the stack, which is z naught, which means it will goes to its final state. Okay, and since it is emptying by stack, the push symbol, which is z naught, again I'm going to push z naught into the stack. Okay, so this is the example for emptying by final state. Okay, so this is the transition function. Okay, next you will tell me the answer. Instantaneous description. Instantaneous description for the input string 2 times A, 4 times B. Okay, so 2 times A, 4 times B. So I will start first. First, Q naught, initial state. The remaining strings had to be read since it is the starting state. The whole string. Okay, then top of the symbol is it not the tan style notation. Okay, okay, you will tell me the answer. Just 1 minute. இன்னைக்கு குளிக்க வச்சிருங்க தலைக்கு எல்லாம் சாம்பிள் குடிக்கிறேன்னா அப்பதான் okay. Q naught. Yes, the remaining strings a single A, 4 times B. Yes, good. What next? Same Q naught. Remaining string 4 times B, then 4 times A is at none. Very good. See, what about others, please? Okay, Q1. Yes, remaining strings 3 times B. Yes, 3 times A is it now. Next, Q1, 2 times B, A is it now. Good. Yes, Q1, B, A is it now. Yes. Yes, Q1, epsilon. Okay, is it not? Yes. But if I'm choosing a final statements, means replacing last epsilon with is it not? Okay. Okay. Very good. So Q naught, the remaining string, first A has been read. So remaining string A 4 times B. Then uh, the symbols available in the stack, that is 2 times A, right, along with Z naught. Next, another times 10 notation, the state Q naught, then remaining thing 4 times B, uh, the symbols available in the stack, so 4 times A, Z naught. Okay. Next, the current state, which is Q naught only. Okay. So 3 times B, then available strings in the stack 3 times A, Z naught, because it is pop operation. So after 1B is proceed, the state which is moving to Q1. Okay, here the remaining string, which is 2 times B, then available symbols A, Z naught, then the the same state, symbol single B, then single times A, Z naught, then uh, the same state Q1. Okay, the remaining string, which is epsilon. Okay, then available, that is Z naught, available symbols in the stack, that is Z naught. Okay, without reading the symbol, it will goes to the state Q2. Okay, then epsilon, the available string, which is if I'm choosing emptying by final state means Z naught. Okay, or emptying by stack means epsilon. Yes, okay. So I'm asking you to take in notes, okay, on this problem. I hope you are having your separate TOC notes. I hope. So almost the today concept is over. Okay. So the problems. So that are almost three problems, right? A power n, b power n. The first problem, a power n, b power m, c power n. Next, second problem, a power n, b power n. Okay, and the third problem, which is a power n, b power 2n. Okay, so again I will give you homework problem, right? That is a parenthesis, which is almost equal to a power n, b power n. Okay, so this is the time for discussion. So any doubt, kindly post in the chat box. So please anyone post in the chat box what is the difference between finite state machine and piston automata. Don't left the meeting. Okay. Stay on the meeting. So the meet attendance, the time in and time out, both are monitored. Okay. I'm asking you to post in the chat box what is the difference between finite state machine. Yes, very good. The first point, finite state machine, which is 5 tuples, and Pushton automata, which has 7 tuples. So next, is there any more point? Yes, no memory in finite state, and you can also tell less memory. Okay, in finite state machine. Here the memory, here actually the stack will act as a extra memory on Pushton automata. Okay, yes, this is the second point. PDA has a stack. Okay, the first point, second point. So any other point? From the tuples itself, you can tell me the point. If they are asking in a part B question, means you have to draw a separate actually diagram. Okay. So see, one more point we can add like finite state machine which has only input symbols, but your Pushton automata as it's along with input symbols, it has stack symbols, right? That is one more point. And PDF type 3 grammar. Anyone please confirm me type 3 grammar or type 2 is type 2 grammar. Yes. This is also an important point. Okay. So PDA it accepts the type 2 language. Okay. Okay. But FDA actually FDA finite state machine it accepts yes. Yes, type 3. Okay. Yes. This is also important point. Finite state machines which accept type 3 and Pushton automata which accept type 2. And if you add one more point means based on the application, can anyone post based on the application? Compiler. Okay. The first phase, you can, the first phase of compiler. Okay, that is lexical analysis. Okay, finite state machines played a major role in first phase of compiler, lexical analysis. Okay, and it has so many restrictions. That is why it can't able to proceed with the second phase. So that is why we will prefer a grammar. Okay, so that is context-free grammar. Second phase, which is syntax analysis. So in that syntax analysis, Pushton automata. Okay, the Pushton, the part of Pushton automata was a major role in the second phase. Okay, this is also an important point. The difference between FDA and PDA, and you can draw on transition diagram, example transition diagram, the graphical notation. Okay, see, if a finite state machine means from the state A, if I'm reading a single by means it goes to B. If pushed on automata means from A to B, what are all things happen? That input symbol, comma symbol on the symbol on top of the stack, and which is going to be popped. Bar the symbol is pushed onto the stack. Okay, you have to draw the diagram. So the points are over. These are all the difference between the points. The difference between pushed on automata and finite state machine. Okay. Okay, thank you, students.